Investigate if the function is injective. A function f of x equals y is said to be injective if each element in x has a different image in y. We can also give the definition of an injective function as one where no two elements of x have the same image in y. This can be stated formally as follows. The function f of x equals y is injective if, for all x1, x2, x is an element of x, f of x1 is equal to f of x2, therefore x1 equals x2. So on an arrow diagram, a function is injective if no element of y has more than one arrow arriving at it. The diagram opposite shows an injective function. So no element of y has more than one arrow arriving at it. So we see 1 goes to 1, 2 goes to 4, 3 goes to 9. So the y values have only one x value connected to it, one arrow connected to each y value. So what we want to do with our function is let it be equal to f of x. So we have f of x equals 3x minus 2. Then we're going to let x1 and x2 be an element of the real number set. Then f of x1 will be equal to 3x1 minus 2, and f of x2 will be equal to 3x2 minus 2. So if f of x1 is equal to f of x2, then 3x1 minus 2 will be equal to 3x2 minus 2. So the minus 2's can cancel out, and the 3's can cancel, leaving us with x1 on the left and x2 on the right. So therefore x1 is equal to x2, thus the function is injective. So we followed this formal definition to arrive at this. If f of x1 is equal to f of x2, therefore x1 is equal to x2. So this is the definition of an injective function. But what this really means in English is that each x value goes to only one y value, and each y value is only connected to one x value. So for example, if we had y equals x squared, this would not be injective, because if I was to substitute minus 2 in for my x value, I'd end up with 4, because minus 2 squared is 4. But if I subbed in 2, I would also get 4. So if I was to draw it out in a mapping diagram, I would have 2 in my x value, 4 my y value, and then I would have minus 2 for my x value, also connected to 4. And I cannot have more than one arrow arriving at y, at any of the elements in y.